And thank you everyone for giving us a little bit of your time today. So picking up on the theme of hybrid workload, one of the key pillars of capabilities that we have at AWS is the ability to now be able to run AWS infrastructure and services on premise, not just in the cloud, in the regions that we support. I'm Lee Cardona, Senior Solution Architect, and I work with large enterprise customers as well as global integrators, helping customers navigate the briar patch, if you will, of moving legacy workloads to the cloud, modernizing workloads, and as well as building robust workloads natively in the cloud. So when it comes to cloud computing, we've all have seen over the past decade the benefits and why many organizations are rapidly adopting and accelerating their use of cloud. We have millions of active customers at AWS, and we hear from them many drivers as to why they are looking to cloud and using the cloud. But the things that tend to stay at the top of the list all the time from what we see in our conversations are the ability of having agility, to be able to innovate faster and to go to market faster. And cloud enables that because you're able to fail faster and pivot if need be, as well as the cost savings with cloud, since you only pay for what you use. So you're now able to do things that you weren't able to do before in a fixed capacity on premise, which is to pay for only what you use and match your workload to your spend. However, as John did mention in the previous session, there are some realities that we still have to deal with workloads that need to be local and require on-premise placement. What we see is that these workloads typically fall into one or two buckets. One is physics, as we would call it, right? Which is to say the speed of light and time as it relates to network latency. So here we're talking about locations that may have poor network connections. So it could be a bandwidth issue, or it could be an actual pure latency issue, that even if you had all the bandwidth in the world, your workload needs to have response times that are not going to be possible with a slow connection that has to send data up to the cloud, process the data, and return it. So a lot of situations that what I've personally seen with customers that are doing things on the factory floor, where they have to have sub-millisecond latency to control machines for human safety and other issues and timing of sequencing of the assembly process, as well as AR/VR scenarios where if you're augmenting your workflow, you're overlaying an augmented reality scene that needs to be computated and then overlaid on your actual real environment. Those tend to have really tight tolerances for latency. So those types of workloads typically require compute capacity to stay local. The other is data, right? Data can fall into several categories. Some of the easier ones are from a governmental or regulatory standpoint and data sovereignty issues. So we see things like in Europe, have customers that are dealing and working their way through the whole Brexit situation, where data that may have been resident in the EU now is not technically in the EU anymore, and vice versa. So based on certain laws, your data needs to stay where it needs to stay and it can't move. Others may be contractual requirements where based on the terms of a particular bid, a customer finds themselves being locked into a certain geography, and that's where the data needs to stay, and they need to conform to that. Now, when we looked at this space, we wanted to try to understand what we could bring from an AWS perspective that wasn't currently in the marketplace. And when we surveyed the landscape, what we saw and heard from our customers was that, all of the developers always kept telling us the same thing. They're dealing with different operating models depending if their workload is on premise or in the cloud. So the cloud environment being much newer from a generational perspective, and very agile and quick versus legacy environments or even hybrid type environments that different vendors bring different parts of a solution together to try to give you a cloud-like experience on premise. That's great, but to the end users that have to use this infrastructure to develop and deploy their workloads and run their workloads, what we've seen consistently is, different set of models for tooling, APIs, and so forth. So we asked ourselves, what if that wasn't the case? Because one of the things that cloud brings, as we said, is ability to fail fast through agility and to be able to innovate and iterate. So we wanted to make sure that anything that we did where we're adding value to the marketplace did not mean that we'd have to give up any of the things that AWS is known for. So what if you could give developers the same services and APIs they use in the cloud to develop applications on-premise? What would that look like, and would that be possible? Concurrently with that, what if IT could then use the same tools to deploy, secure, and operate IT resources, whether it was on-premise or the cloud? So there's no need to retool, there's no need to retrain, and there's no need to refactor anything from the cloud to get it to work on-prem and vice versa. How will we accomplish that? And that's where we set out to bring AWS Outposts to market. AWS Outposts brings AWS Infrastructure, Services, APIs, and tools. And when we say AWS Infrastructure, Services, API, and tools, we literally mean the same identical physical infrastructure that we run on in our own data centers in the regions, the same services that our customers use day in and day out, the same APIs, and the same tooling that they've built around all of AWS capabilities. And to be able to take AWS Outposts to any premise, on-premise facility, as long as there's reliable network connectivity for a truly consistent hybrid experience. So that's the key piece that we really wanted to nail with AWS Outposts, deliver a consistent hybrid experience. So Outposts is designed to be delivered to formal data centers that are built with the proper flooring and environmentals and connectivity for other high density compute workloads where things are in racks and so forth. Co-location data centers, as you heard John say, there's a big trend moving from your own data center and having to run the cost of all that to moving to co-locations on your way to cloud or in combination with cloud, as well as any on-premise facility that can meet the connectivity requirements as well as the physical requirements of housing a piece of equipment that's a full rack and has the weight of that depending on your configuration and the AC and HVAC requirements for airflow and so forth. Now, in talking to our customers, once we presented the proposition of Outposts, we've asked them, what use cases would you be using something that Outposts could bring to you for? And what we've heard are a whole array of use cases. Yeah, you heard me mention a little bit before, like factory floor, where you have AR, VR, so there's like the 3D modeling, but they also span other things, such as autonomous vehicles and fleet management, where you need to be as close as possible to the end device as it's doing near real-time calculations to determine navigation and possible autonomy, right? You have other needs around real-time patient medical diagnosis and medical imaging, where time is critical. And as well, live events and gaming, as you'd imagine, those ping times, you want to keep them as low as possible. No one wants to lose a round of a game because their latency shot through the roof. So with compute infrastructure closer to the edge, closer to where the end users are using the services, this is where Outposts really shines. So to get started with Outposts, you order from a full range of fully integrated and pre-validated configurations that are best suited for your use case. So if you're already familiar with our existing Elastic Compute Cloud EC2, you'll be familiar with the various family types and instance types that we have there. And you use that to determine the total capacity you would need for your AWS Outposts. So for example, you simply would select from a list that's provided to you within the console, the instance types you would like. So you could say here general purpose or M5 instances, or maybe our memory optimized or R instances or R5, as well as any of our GPU instances, which Outpost supports our newer G4 instances as well. And then you have the option for storage to have local as well as EBS, local storage as well as EBS storage for volumes, as well as Amazon S3 announced last month as now being available locally on the Outpost. Once you've configured your order and hit submit in the console, that kicks off the process. And ultimately, we work and coordinate with the customer to determine a date for installation. And we literally show up on site with our installation and engineering team to basically prepare the Outpost, install the Outpost, and then make sure everything's done and operating. So, you know, AWS certified personnel will deliver and install it to your facility. So we show up on the day of the facility. It typically takes about half a day. And once there, not only do they uncrate and validate and check that everything is where it should be, they then also put it in position, ensure that everything that previously was surveyed matches up, and we simply then plug it into power, right, which can vary from country to country, location to location, and in multiple connection types in different data centers. And we have different means of supporting all of those. And then also then connectivity at the network layer, and we'll talk a little bit more about this. But once you have power and connectivity, our installation team starts to bring the Outpost online for you. And again, as I mentioned, that takes about a half a day, depending on the configuration and what's ordered, and depending on how many actual racks are ordered. So you can order one, or you can order a whole bunch of racks that could constitute one logical Outpost deployment. Once the Outpost is brought up and is online, it does establish a connection back to a parent region. So all the regions that we have around the world are there so that the Outpost can reach back. And this is how we are able to manage the Outpost for our customers and make sure that metrics are being captured and so forth. Now, that connection is encrypted end-to-end, and it's also outbound initiated, meaning that it's the Outpost that initiates the connection back to the parent region, not the other way around. So there's no need to have to get firewall ports open and so forth. So it's very secure. It's only outbound. Once it's established outbound, then within that encrypted tunnel, the communication can be bidirectional. On top of that, you're able to leverage our VPN service if you want to further envelop that connection within a VPN to add another layer of encryption, as well as have that run over a direct connect connectivity so that it's a private connection and totally sidesteps, say, the internet for you. Both options are available. Now, on premises for low latency access, right, which is what key here to what we're doing with AWS Outposts, you can create what we call a local gateway. So if you're familiar with our cloud VPC, virtual private cloud setup, where you are able to have a virtual private gateway to provide connectivity into your virtual private cloud, as well as your internet gateways and so forth. So these are gateways that sit at the edge of your virtual private cloud with AWS. With AWS Outposts, you're able to create a new logical network device that we call the LGW, or local gateway. And the purpose of the local gateway is to provide logical connectivity in a reliable, redundant manner to your on-premise networking equipment that the Outpost gets connected to physically. So as part of the setup, as I mentioned earlier, the AWS certified install technicians work with the point of contacts and technicians on site and literally physically connect the Outpost network equipment that's in the Outpost rack to a pair of routers or switches, and anywhere from 1 gigabit up to 100 gigabit connections. And we do that in a redundant fashion, physically speaking, from multiple fiber connections. Once that's in place physically, then the logical configuration is established, which then allows you to create the LGW that utilizes this physical underlay infrastructure I just walked through. So as you can see here, you get VIF1 and VIF2, similar to how a direct connect connection is done today, if you're familiar with that. And then that establishes a connection between the customer gateway devices and the LGW. At that point, there's connectivity as controlled by the customer from their local area network to the Outpost and vice versa. Again, that entire demarcation is secure and controlled by the customer, as open as they need it to be for their local network, or as closed as they need it to be. Now, once this is established, what's the experience like? Well, from a networking perspective, first, it is seamless. Nothing new, nothing different. You're back inside the AWS console that you'd be familiar with using our services in the AWS regions. And you simply would, create a VPC like you would today, or take an existing VPC, and then you simply can extend that VPC by creating a subnet and associating it with the Outpost. So you can see here on the diagram below, you have the AWS region, right? So this would be the parent region that a particular Outpost is connected to, we talked about earlier. And as you can see here, there's a VPC that has one subnet, and that subnet is in one availability zone. So when you add Outposts to the picture, as you see here, we've added 2 actual Outposts physically to this picture, that the VPC at the top can be extended to utilize the capabilities that are on the Outpost simply by creating subnets, but picking the Outpost as opposed to picking availability zones. So very similar to what you do in the AWS console, you just now have as a selector, not just availability zones where you would put a subnet, you now have the ability to say, I want to have a subnet in this particular Outpost. And what's depicted here is that such example, that someone would have gone through, created 2 subnets, one in each of those Outposts for the top VPC, and thereby extending that logical construct over. On the bottom, you can have another VPC. You're not limited to just one VPC. And again, creating a subnet for that VPC, targeting the Outpost would extend that VPC into the Outpost. So from an underlying network perspective, identical to how things are done today, you just have a new target of where you could put your subnets. And all the benefits of the networking that you are familiar with in Amazon VPC, which is to say private addressing, access from subnet to subnet based on how you configure your route tables and how you configure your ACLs and your security groups, all apply. Now, once you want to launch actual compute resources, such as EC2 instances, to run your applications Outposts, again, nothing new to learn here, actually. It's quite dull, intentionally so that you can get up and running quickly. You use the same AWS console or the CLI or any of our SDKs that you would use today. The key here is that because of this, no retooling needs to happen. So if you're not using the console because you have an already fully integrated pipeline where it's automated deployment based on some type of event that kicks off a request, say from a team, and then that ultimately delivers EC2 instances to them, that same pipeline can now just target Outposts, and it'll just bring up the EC2 instances the same way as before. So nothing changes from a end user experience on how to get the compute you need. Now, in addition to compute, you could also run a range of services locally on the Outpost. We show here a handful of them, and more are coming. So today you can run, if you need to run container-based workloads, you can utilize our Elastic Container Service or ECS, and you can run those containers in ECS on Outposts. Also, if you're a Kubernetes shop and you're running containers utilizing Kubernetes as your orchestration and management layer, you can run our managed EKS service or Elastic Kubernetes service, also on Outposts. We already talked about S3, which has always been in the region for AWS, now is available locally for quick access to object storage where you need it on premise. And then from a enterprise relational database perspective, you can take advantage of our relational database services and have access to the database engines such as MySQL and Postgres there. And if you have any analytic-based workloads where you need to utilize MapReduce, you can utilize our managed Elastic MapReduce service and have that running locally, and all the analytics and processing and output happen locally on the Outpost as well. Now, for services that aren't available locally, you can still access these services through our public service endpoints, or since you're now inside of VPC within the Outpost, you can also still use our VPC private link services to get private access to those endpoints, just like you would in a regular VPC. Now, from a capabilities perspective, that was all well and good, but here's the key differentiator you always want to remember with Outposts. Outposts, like all of our other services, are fully managed and supported by AWS. This is not a piece of hardware that's being sold. This is a fully managed service that has a large component of hardware at the core. So what does this mean? This means that it removes the overhead of undifferentiated heavy lifting for on-premises infrastructure that you would typically be accustomed to until now with AWS Outposts. So for example, there's no need to worry about downloading updates to keep everything patched and so forth with the underlying hardware or any of the hypervisor layer and everything you need to get virtualized workloads up and running on hardware. That goes away, right? As well, the actual hardware itself is all supported and maintained by AWS. Should something go wrong and something need to be replaced, AWS shows up, removes the defective component, adds the new replacement component, and you're back up and running. As well, there's no multiple vendors involved here. This is solely a fully AWS managed offering, so you only have to deal with AWS for the entire stack, hardware, software, and service, all through one simple interface. Pick up and create a ticket in our console, get on the phone, get with your account manager, and your support is straightforward. For customers that need some assistance with some of the aspects of this or want to use some partners for different solution sets that are above and beyond what we offer, our AWS partner network is there, and we have a broad array of AWS partners that are standing ready to support solutions on Outposts, from installation and maintenance to migrations of workloads from on-prem to AWS, but still on-prem on Outposts, to the networking pieces that I talked about and how to get all that set up properly and done, to the storage aspect, if there's going to be third-party storage integration that's also currently on-prem with the storage that's on the Outpost, how to integrate that, as well as various security solutions that different partners bring to add to the security that AWS offers. Now, when we talk about security, there is no difference here with AWS Outposts. AWS secures the Outpost just as it secures the infrastructure in the cloud today. So you benefit by getting all of our industrialized security that we have on our physical equipment in our own facilities, right? So the Outpost is very robust. It has an array of sensors in it, so it knows when if it's been tilted when it's being delivered. So we would know we're not going to install something that's potentially been damaged, even though you can't physically see it with human eyes, as well as making sure all the air quality and so forth needed to operate it efficiently is done well. Also, you can't remove any of the components in the Outpost because they all have physical keys that lock them in place that are tied into the Outpost, so that should a component be defective, for example, and we need to swap it out, the technician, upon removing it, that key erases any data on that particular component so that the customer's data never leaves the facility. So think of it as a shredder, basically. And that's the same type of security capabilities that we have in our data centers. And that's now made available to our customers on premise. There is one difference though, and the difference is that customers, while again, like in the cloud, are still responsible for running applications, the security of the applications running on the Outpost. In this case, the Outpost is not physically in an AWS facility, it's in a customer facility. So the customer does take on the additional responsibility of the physical security of the Outpost, right? So that's a different component to our shared responsibility model that we have already in the cloud with customers. So that's part of the reason why we ask questions as to where's the facility, is it able to properly handle the equipment, and is it properly securable? So I'll wrap up here just by saying that our Outposts, I think we feel that, and we've seen a lot of great response with it after being launched at last year's reInvent, that customers now with AWS Outposts truly can extend the capabilities of AWS on-premise and achieve a truly consistent hybrid cloud experience from on-prem to cloud and vice versa. So with that, I will leave you with just some links here on how to get started with Outposts. So again, just /Outposts on our website, awsamazon.com, as well as in the console to get you right to the console for Outposts. There's a picture depicted there on the right-hand side showing you what an actual Outpost rack looks like. The exact configuration varies, again, based on what the customer orders, but that's generally what it looks like. And as you can see, everything's lockable with front and back doors and very, very secure.